Alright, so we were supposed to classify equations. What I'm going to do is go through not only what the classification is, but exactly how you can figure it out. So if we're going to classify it first, we need to figure out what's going on. So you've got 4 classifications you've learned about so far. You've learned about single replacement, double replacement, and then before that we learned about synthesis and decomposition. And so you have to know what those are to kind of figure it out. So synthesis is when you take a couple of smaller or simpler compounds and put them into a more complex compound. Decomposition is the opposite of that, where you have a more complex compound that's broken down into simpler pieces, more than one, either a substance or an element, broken into simpler substances, either elements or compounds. Single replacement means you're taking a one-part substance and replacing some part of a two-part substance. Double replacement means you have two-part substances where you're switching parts. Okay, that's kind of a real simple definition. All right, so let's look at these for a minute. All right, I have an Na here, and over here it's joined up with something else. Okay, so it's joined up with the back of this thing. There's the OH it joined up with. Okay, and I have the Ca, the calcium, that's over here. It's joined up with the Br. Well, that means it had to join up with the back part of this. So if you switch two things like this, that's double replacement. Okay? So that's a double replacement reaction. All right, now to balance the equation then, you're required to use an atom inventory process. And for that, we're going to first list all the elements we have. And then we're going to arrange a kind of spreadsheet or grid here. And then we're going to count all of the atoms of each type on either side of that arrow. And that's why I have this line down the middle underneath the arrow, so that I can keep all the atoms on this side as one count and all the atoms on this side as a different count. So we're actually doing, you might say, 2 different inventories. We call it an atom inventory. So over here I have 1 sodium, 1 bromine, 1 calcium. This 2 outside the parentheses here means that I am multiplying, everything inside the parentheses by 2. So I have 1 oxygen here in this polyatomic ion, and I'm multiplying it by 2. That means I have 2 oxygens, and I have 2 hydrogens. Over on this side of the equation then, I've got 1 calcium. I've got 2 bromines. This subscript 2 means there are 2 bromines bonded together and bonded with this calcium. So that's 2 bromines. And over here I have just 1 sodium. And I have just 1 oxygen. And I have just 1 hydrogen. And what I need to do is to get the numbers on both sides of my inventory to be the same. And I can only use coefficients to do that. Once these formulas are balanced, and I gave you balance formulas, once they're balanced, then you can't mess with the balance. You can't put any numbers inside the formula. The only thing you can do to balance these numbers here is to use coefficients. That's big numbers in front of each of these formulas. So remember, we're going to save oxygen for last and hydrogen next to last. We want to start then with bromine. I've got 2 on the right side and 1 on the left. The only way that I can get 2 bromines on the left is to put a coefficient in front of the entire formula that includes the bromine. And that's going to change both the sodiums and the bromines. So I'm going to mark a line through that and put a 2 here. So I've got 2 sodiums, and that 2 also applies to this because it applies to everything in the formula. So I've got 2 bromines now. All right, so that unbalanced the number of sodiums. So I want to go over here and find a way to get 2 sodiums now. And for that, I have to use only coefficients. I can't stick numbers in the formulas. They're already set. So I'll put a 2 out here in front. And that means I'm going to have 2 sodiums. That 2 applies to everything in the formula, so it also means I have 2 oxygens, and it means I have 2 hydrogens. And now my equation is balanced. Okay? Got it? All right. The next equation I asked you to work with, finding the classification and balancing, was this one. So we have 4 types of classification of equations to work with so far. And this is one where I'm taking 2 simple substances and combining them together into a more complex substance. And that is, by definition, synthesis. Okay? I'm putting these together to make that. Okay? But it's not balanced yet. We still have to do that. So this is a synthesis reaction. So that's the correct classification. We want to write an atom inventory now. We're going to list all of our elements on the left. It's just 2 of them here. Make a kind of a simple grid. Okay. Count up all the elements we have at the moment. We have 1 phosphorus and 2 oxygens. We have 2 phosphoruses, or phosphori, I guess, on the right side. And how many oxygens do I have? 5. Okay. So I need to try to get everything balanced. I want to start with the phosphorus. Remember, we always save oxygen for last. So we're going to try to get 2 phosphori. We'll put a 2 coefficient in front to give us 2 phosphori, but that won't fix the oxygens yet. I have 2 oxygens on the left and 5 on the right. I got an even number on the left and an odd number on the right. Okay? What I want to do is to figure out a way to get both of them up to the same number down here. Okay, if I multiply this by 2, that only gives me 4. If I multiply this by 3, that gives me 6. That's more than I need. Well, the rule that I've given you is when you have an odd number on one side and an even number on the other, you want to go through and multiply everything by 2 except the species that is just O2. And then come back and fix that one. So let's change this one, first of all, to a 4. And let's put a 2 in front of that. So we're multiplying this species by 2 and this species by 2. See what I did? So that changes this now from a 2 to a 4. We're going to go over here, and that gives us 4 phosphoruses, and it gives us 2 times the 5 oxygens, because this 2 applies to everything in the formula. We start out with 5 oxygens, so it's 2 times 5 oxygens, or 10. And now when I go back and try to balance for the oxygen, that's fairly easy. I just put a 5 in front, and I get 10 of those. Okay? All right, so that was the second equation I asked you to do. The third one was this way. So we have a somewhat more complex or larger compound here and 2 smaller compounds over here. So we're making 2 smaller compounds out of a larger one. And what definition does that fit? Decomposition. We're decomposing it. All right, so that's the classification. Decomposition. Let's list all of our elements to do the atom inventory and balance the equation then. Okay. I try to always put this middle line here underneath the arrow because I'm trying to keep the numbers of elements on this side separate from the number of elements on this side. So I've got, Mason, how many potassiums do I have here? 1 to start with. I'm going to print out a sheet yet for you guys to do that. Take roll. So William, how many chlorines do I have?
1.
Okay. And then, Naughty, how many oxygens do I have on the left side? 4. Okay, so 1, 1, and 4. 1, 1, and 4. All right, on the right-hand side then, Hannah, how many potassiums do I have? 1. Okay. And Ivana, how many chlorines do I have? That's an S. In parentheses, that's the physical state. 1. Okay. And Jonathan, John, how many oxygens do I have on the right side? 2. Okay. So what I want to do is try to get the numbers to be the same on both sides. And we always save oxygen for last, but it's the only one that's not balanced right now. So we start with oxygen in this case. Put a 2 in front of that, and that fixes it. That's a fairly easy one, isn't it? Okay. All right, then we got one more equation you were supposed to do. aqueous. Now we learned to name acids in the last unit. Anybody know how to name that one? This acid right here. Unit 4 was all about nomenclature, naming compounds, and we learned to name acids. How do you go about naming an acid like that? Does anybody remember that? You're gonna need it. How do you name an acid? Like this one anyway. You start out naming it like what? Like it's a ionic compound. So this is hydrogen. Huh? It is phosphate. Right. So you name it like hydrogen phosphate. And then how do you change that when you have an acid like this one? Huh? You do what? And change it to what? IC. Okay, good. And then what about the hydrogen on the front? What do you drop it entirely? When you have a polyatomic oxyanion in an acid, you change the AT ending to IC, and you drop hydrogen off the name of it altogether. So this is, and since this is phosphorus, we're going to put that OR syllable back on there, phosphoric acid. Okay? You need to remember that. Got a midterm next week, so that's going to come. Those kind of things will come back on the midterm. Okay, so that's the next thing we need to talk about. This element here appears to be joined up with that phosphate on this side. Okay, so what it's done is it's gone over here and it's replaced this hydrogen, and the hydrogen is going to be by itself then. Okay, and this compound, this and the phosphate, the lead and the phosphate are together. And that's the definition of single replacement. Okay, one simpler part, substance, replaces some part of a complex formula or compound. Single replacement. Also called single displacement. It displaces the hydrogen. Okay, so let's balance the equation now. We got a lead here, and a hydrogen, and a phosphorus, and an oxygen. We got 1 lead, 3 hydrogens, 1 phosphorus, 4 oxygens. On this side, I've got how many leads? 3 leads. Where did I stop a while ago? Ty, you just answered 1. Okay. Laura, how many hydrogens do I have on the right-hand side? 2. And Alexander, how many phosphoruses do I have on the right side? 2. And Gracie, how many oxygens do I have on the right side? 8. Okay, it's 2 times the 4 that are in the parentheses here. All right, so let's start with the lead to try to fix it. What do I do over here? Michael? Put a 3 coefficient. That changes that to 3. All right, what about fixing the hydrogens then? Tevin, how do I fix the hydrogens? I got 3 on the left and 2 on the right. What am I going to do?
Multiply by 2 and 3.
Okay, so I multiply this one by 2 by putting a coefficient 2 in front, and this one by 3 by putting a coefficient 3 in front. That changes everything inside here. So now I have 2 times 3 or 6 hydrogens. Okay, Nithpasong, how many phosphoruses do I have? 2 of them. Okay, and Sam, how many oxygens do I have now? 8. Okay. Well, let's see. Over here on this side, I haven't multiplied this one out yet. So, Logan, let's see. How many hydrogens do I have here? 6. Well, we're fixed then, aren't we? Okay. All right.